Hello everyone. Am I audible? Please let me know in the chat box if I am audible. Yes, everyone. Am I audible? Please let me know. I think I am right. Okay, then let us start with the lecture. Am I audible? Please let me know in the chat box. Good evening, everyone. Good evening, dear students. Hello. Am I audible? Am I audible now? Please let me know. Hello. Hello. Am I audible? Okay, hello. Then great. Let us start with the lecture. Okay, then great. Let us start with the lecture. See. So, our topic for today is frequency domain analysis. Questions based on frequency domain analysis. Okay. So the first question, if you see, now we definitely know, whenever we talk about frequency domain, we have got something called as Nyquist plots. So some different plots are there. Let me just tell you what are they. Just a quick introduction. Basically, you have been given with a system, correct? Yes. Now, the first thing is we are supposed to find what we are supposed to find whether the system is stable or not. Stability, kind of. Correct or no? Yes. We need to find stability. So, in order to find stability, we have got two ways. One is time domain approach, and another approach is nothing but frequency domain approach. Means we are going to find the same thing, but we are having two different approaches. Correct? Getting my point? Yes. New subscriber. Good evening, brother. Yes. So this is the way we know. Now see, we are supposed to find the same thing, that is stability, but now we are going to have some different approaches. The first approach will be nothing but time domain approach, and the second approach will be nothing but the frequency domain approach. Now, in frequency domain approach, we need to find some plots we need to find, and the plots are, the first one is Bode plot. Then we need to find something called as polar plot and something called as a Nyquist plot. Getting my point? Yes, Nyquist plot. Now see, all of them give you relative stability. Means all of these things, these plots will be definitely giving you something called as gain margin and something called as phase margin. Correct? And we know that if both of them are positive, then we say that system is stable. Correct? Just a quick recap to these things. Let me tell you what is gain margin and what is phase margin. Gain margin is what? Whenever we say margin in the sense, see here, whenever we talk about margin means what? Margin means how much gain I can increase in the system such that system will still remain in stable form. Means my system is there, which is a stable system. Now, if I want to increase the gain of the system, then up till what value or how much space do I have in order to increase the margin such that my system will remain stable? That is nothing but gain margin. And the similar case goes for phase margin. It tells you how much phase you can add in the system and the system will still remain stable. How much is the space remained in the system so that it will remain. So this is how it is. And now we know that if both of them are positive, then in that case the system is going to be stable system. Is that correct? Yes, sir. Okay. Anyways, now the let us move on to the first question. What is it? The first question is the polar plot of g of s equal to 10 upon s into s plus 1 the whole square intercept real axis at omega equal to omega naught, then the real part and omega naught are respectively given by, means we are supposed to find real part and omega naught of this particular system. How do you do that? See here. What is the transfer function given to you? This is open loop transfer function, correct? What is that? G of s equal to how much, sir? G of s equal to, sir, 10 upon s into s plus 1 the whole square. Is that correct? Yes. Now they are saying that it intercepts the real axis. Real axis in the sense what? And it intercepts the real axis at omega equal to omega naught. Real axis in the sense axis of x. Correct. We miss x-axis. Real axis is nothing but which axis, sir? X-axis. Now they are saying that this intersecting with the real axis means it is somewhere here. So here we know angle is what? This is 0. This is minus 90 degrees. This is minus 180 degrees, which means it is intercepting somewhere here and at angle minus 180 degrees. Correct or not? Therefore, we need to equate the angle of this particular plot to 180 degrees to minus of 180 degrees. So this is angle of G, which is equal to minus of 180 degrees, which is equal to how much? This total angle. Correct or not? Yes. Now, what will be the total angle? This total angle will be what? See, this S, it is a denominator. It will be replaced by j omega. Similarly, this S here, it will be also replaced by j omega plus 1 the whole square. So down you have got S, which is having j omega. So if that j goes up, it will become minus 90 degrees. In the similar way, we can have this one, which is what? Minus 2 times tan inverse of omega. Is it correct? Yes. Now, so from this, what do you get? Therefore, if you keep this one on the other side, you get minus 180 degrees plus 90 degrees, because this minus sign will become plus sign, and this will be equal to minus 2 times tan inverse of omega. Is that correct? Yes. Now, minus 180 plus 90 degrees is how much? Minus 90 degrees, which is equal to minus 2 times tan inverse of omega. Correct? Yes. Now this minus minus will get cancelled, and 90 degrees upon 2 will be nothing but tan inverse of omega. So tan inverse of omega will be 90 degrees upon 2, which is equal to 45 degrees. Correct? Yes. Now, for what value of omega will my tan inverse of omega become 45 degrees? So we know that the answer is 1, because we know tan of 1, sorry, tan of 45 degrees is equal to how much? Is equal to 1. Therefore, we know 45 degrees is nothing but tan inverse of 1. Now here, if you please compare 45 degrees is there. Tan inverse is there. So you get omega to be equal to how much? Omega to be equal to 1. Therefore, you get omega value to be equal to 1. Therefore, omega equal to 1. Now, since angle of G is equal to minus 180 degrees, we have equated here, correct? We have equated that angle of G is equal to minus 180 degrees, which means it is definitely which frequency? This frequency will be now called as phase crossover frequency, correct? Phase crossover frequency. Is that right? Yes, sir. Now, therefore, if it is phase crossover frequency, if it is called as phase crossover frequency, then what is happening? See, what is angle of what is magnitude of G at omega equal to omega pc? What is that? That is nothing but this will give you gain margin, correct? So this is equal to 10 upon how much? Omega equal to omega pc. So omega equal to, so s into s plus 1 the whole square. So omega into 1 plus omega square, because we know s can be replaced as j omega, and we are interested in the magnitude. So magnitude is nothing omega square. That's it. If you please replace omega equal to omega pc, means 10 upon omega. What is omega? 1 into 1 plus 1 squared. What is that equal to? 10 upon 1 into 2. So 2 ones are 2 fives are, and you get answer to be equal to how much? 5. Is that correct? Yes. Which means at what point is my polar plot crossing is nothing but phi. But now this phi has to be which phi? It has to be negative phi. So because they've given that at omega equal to omega phi, the intercepts at real axis at omega equal to omega naught. Therefore, this is definitely which point? Minus phi. Getting my point on it? Yes, sir, definitely. Therefore, your answer is nothing but what? What is your answer? Omega naught. What is value of omega naught? Omega naught just now we got equal to how much? Omega naught just now we got equal to omega equal to 1 and this is 5. So it is minus 5 comma 1. So answer is option C. Getting my point? Is it very easy? Please tell me. Please tell me, Bachalo. Is it very easy? Any doubts in this particular question so far? Please let me know if you have any doubts. Any doubts in this question? Okay, so now let us move on to the next question. Let us see question 2. The gain margin in dB of a system having the loop transfer function g of s h of s equal to root 2 upon s into s plus 1 is the thing. Okay, now what are you supposed to do? You're supposed to find the gain margin, correct? Now, there is one property we need to understand. What is that property? See here. This particular system which is there, you please tell me what is order of this system? What is order of the system? This system is nothing but second order system, correct or no? Correct or no? Yes, this open loop transfer function order. Basically, it should not be called as order only, but still, this particular thing, is it a second order function? Rather, I can say the second order function, correct or not? Yes. If it is second order, why? Because s into s is giving you s squared into what do we say? S squared plus s, correct or not? Yes, s squared plus s. So basically, it is a second order function. And if it is a second order function, then in such a case, we know that always remember your gain margin is equal to infinity. What is that? Gain margin is equal to infinity. So your answer for this question is option D. Getting my point? Getting my point or not? Please tell me. Yes or no? Yes, sir. Correct. Now let us move on to the next question. What is that? The Nyquist plot of g of s h of s equal to 10 upon s squared plus 1 plus 0.5 s into 1 plus s is. How will that Nyquist plot look like? So basically they are saying that we will start at omega equal to infinity in first quadrant and terminate, and some stuff they are saying. Let us verify that. See, g of s h of s equal to 10 upon s squared into 1 plus 0.5 s into 1 plus s. Now just replace s equal to j omega. Just replace s equal to j omega. The moment we replace that, we get g of j omega h of j omega. So g h of j omega equal to 10 upon j omega the whole squared into 1 plus 0.5 j omega into 1 plus j omega. Correct on this. What is it equal to? 10 upon j omega squared. Is it minus omega squared? Because j square. What is j? J is under root of minus 1. Under root of minus 1 ka square is nothing but minus 1. So it is minus omega squared into what? 1 plus, not that phone 1 plus, it is 1 plus 1 plus 0.5 j omega into 1 plus j omega, correct? Yes. Now let us find the magnitude and angle. Means let us find m phase, m at an angle phi. So let us try to find those. If you try to find the magnitude, what is the magnitude? Let us consider what happens at omega equal to 0. Omega equal to 0, what happens? Let us see. Omega equal to 0, what is m? M is magnitude. What is the magnitude here? Let us see. First of all, if you want to find magnitude, then we need to represent this one in terms of magnitude. So what is that? M phase, let us represent. M in this is 10 upon omega squared into what is this? Under root of 1 square plus how much? 0.5 omega the whole squared multiplied by what? Under root of under root of 1 plus 1 squared plus omega squared, correct? Yes or no? Because x plus iy magnitude is given by under root of x square plus y square. So this is you have. Now what happens at omega equal to 0? Omega equal to 0 you get omega equal to 0. You get just replace omega equal to 0. What do you get? You get 10 upon 0, which is infinity, because omega square 0 square and 0 multiplied by anything is 0, and any number divided by 0 is nothing but infinity. So you have got a magnitude to be how much, sir? Infinity. Now what about angle, sir? Phi. What is angle? What is angle? Angle is, just observe, see, this is minus omega square. Let us find angle also. What is that? 10 upon how much? See, minus omega square. So angle is directly given by minus 180 degrees. Yes or no? Because it is negative. Rest will become 0. No? Angle of this plus angle of this plus angle of this, correct or not? Yes, rest will become 0. So angle is minus 180 degrees. So phase phi is equal to minus 180 degrees. So you only tell me what happens here. What is the answer? What do you think must be the answer here? Nyquist plot? Yes. The figure, because it is starting at omega 0. So the figure will look like magnitude is 0 and angle is minus 180 degrees. So it will go like this. So here it is omega equal to 0. Here it is omega equal to infinity. What happens at infinity? Again, the same story will happen. It will become 0 and it will move like this. So basically it is what? Basically the answer is what? It will start at infinity in first quadrant and will terminate at 0 in second quadrant. That's it. So answer is option A. Getting my point? Is there anyone who has not understood this question? Any doubts in this question so far? Please let me know if there are any doubts in this question. Correct? Okay. So just a minute, I'll have some water. Yes. Now let us move on to the next question. What is that? See, the next question. Which of the following is the Nyquist diagram for the open loop function? Is they are asking. Which of the following is the Nyquist diagram for the question? Now, what is the Nyquist diagram given? What is the transfer function given? G of s into h of s equal to how much? 5 upon, they have given s into 1 plus 0.1 s into 1 plus 0.01 s, correct or not? Yes. Now, what happens that let us write m phase and omega. So what is g h of j omega? Just replace s by j omega. What do you get? 5 upon j omega into 1 plus 0.1 j omega into 1 plus 0.01 j omega. If you try to find magnitude and angle phi, you get magnitude how much, sir? Numerator magnitude is 5. Denominator here it is omega. into under root of how much? 1 plus 0.1 omega. So 1 squared plus 0.1 omega the whole squared. Correct or no? Yes. Multiplied by under root of 1 squared plus 0.01 whole square. Correct or not? Correct or not? Yes, sir. And what about angle? At an angle. Numerator angle is 0 degrees. Minus 90 degrees. Minus tan inverse of, we know, tan inverse of y by x. So this is tan inverse of omega 0.1 omega by 1. So tan inverse of 0.1 omega. Minus tan inverse of how much? 0.01 omega. Correct? Is it right? Yes. Now let us see what happens at omega equal to 0. Let me use another color for that. Yes. So if I see what happens at omega equal to 0, what happens? Omega equal to 0, what is M phase? Omega equal to 0, phi by 0, because phi upon omega 0, 0. So it is infinity. What about angle phi here? What about phi? It is what? Minus 90 degrees. Minus tan inverse of, come on, tan inverse of 0, 0. Minus 0. So it is minus 90 degrees. Basically what? It is starting at infinity and minus 90 degrees. Infinity and minus 90 degrees in the sense what? Infinity and minus 90 degrees means it is somewhere starting here, because this is 0, this is minus 90 degrees, this is minus 180 degrees, this is 270 degrees. Correct or not? Yes. So it is starting somewhere here or not? Yes, definitely. The moment it is starting somewhere here, which means now let us see where it is ending. So somewhere here, which is the option? Is it A, B, C, or D? Yes, definitely. Answer is option C, because it is only starting at infinity at an angle minus 90 degrees. Correct. First tell me yes or no. Is it right? Correct. Correct. Is it very easy? Is it right? Any doubts in this question so far? Please let me know. Any doubts here in this question? No, right? Okay. Now, the Nyquist plot shown below matches with the transfer function. When a, see, this is the transfer. This is the Nyquist plot given. Now, always remember one point. Whenever a pole is added at a negative rear axis, what did I say? Whenever a pole is added at negative rear axis, the tail of the plot remains at same position. Means whenever a pole is added at a negative real axis, what happens at that time? The tail of the polar plot or the Nyquist plot remains at same position, whereas its head of polar plot shifts by 90 degrees clockwise. Shifts by 90 degrees clockwise. So by this logic, what do you think is the answer? It is nothing but option B. Correct or not? Because they are saying that the head gets shifted by 90 degrees. The rest of the thing remains same whenever a pole is added to the negative rear axis. That is the concept. So your your answer is here option B. Now next, the phase margin PM, The phase margin PM and the damping ratio zeta are related by. By the way, just I wanted to tell you one thing here. Whenever we talk about zeta, many institutes or many times students tend to write zeta as damping factor. Correct? Yes or no? Many of the students can do this mistake. So this damping factor, always remember, it is not a damping factor. It should be called damping ratio only, because zeta is equal to what? Zeta is equal to actual friction upon critical friction. Actual friction, whether actual damping upon critical damping. So it is always damping ratio. Whereas damping factor when we say it is nothing but equal to zeta multiplied with omega n. Then it is called as damping factor. Otherwise, it is just a damping ratio. Anyways, let us not get into this stuff. Let us see our target. What is they given? What have they given? They have given phase margin and the damping ratio zeta are related by. Basically, they are asking you the formula. Let us try to derive the formula. Is gate pattern going to change this year? Nobody. The gate pattern will remain the same. You will be having some MCQ question. You will be having MSQ questions also. Multiple select questions will also be there in exam. Like in gate 2021, used to have the same way. This time also, it will be there. The pattern, as in see, the weightage which is there, it will differ. But if you talk about the pattern means how many 2 mark questions are there, how many 1 mark questions are there. That will remain same. And by the way, in your gate exam, always remember, on the top of your question, whenever you start the exam, at the top of your question, it will be mentioned whether it is MCQ or it is MSQ. So please be aware about it first. Okay. Anyways, now the phase margin is what we need to find. So let us start with the derivation. It will be a simple derivation. No much headache will be there. See. Let's see. See here. G of S, H of S. Let us consider a standard second order system. What did I say? Standard second order system. Let us consider. What will I consider? Let me have G of S into H of S. G of S into H of S equal to omega n squared upon S squared plus 2 zeta omega n S plus omega n squared. So S into S plus 2 zeta omega n. Correct? This is the standard second order transfer function we know. Now let us replace S by j omega. Let us replace S by j omega. What happens? Let me divide this into half so we'll get more space. So you get just a minute. Yes. So let us consider G of j omega, H of j omega equal to omega n squared. Just replaced by j omega. So S is replaced by j omega, you get j omega plus 2 times zeta omega n. Correct or not? Yes. Now, what happens at gain crossover frequency? What happens at gain crossover frequency? What is that? Omega gc. Gain crossover frequency also called as omega gc. Correct? Yes. Now, what happens at Omega GC. Let us see. Mod of G of J omega H of J omega is nothing but equal to 1 at omega GC. So let us equate that. So for that, what will happen? Let us find the mod. How will you get the mod of G of J omega? So it is omega n squared upon J omega. Modulus of J omega is omega GC, because we are interested at omega equal to omega GC, correct? Yes. Omega GC into under root of what? Omega GC the whole squared plus 4 times zeta squared into omega n squared, correct? Which is equal to 1. Now see, omega n squared, if I keep it here, let us take this whole denominator on the other side. What will happen? You get omega GC into under root of omega GC the whole squared plus zeta squared omega n squared. Let me take squaring on both sides. Let me do squaring on both sides. I get omega n raised to 4 equal to omega GC ka squared into 2. This under root will go away. Under root will go away and I will get omega GC the whole squared plus 4 zeta squared omega n squared. Correct or no? Please tell me yes or no. Yes. Therefore, what do you get? Omega GC to the power 4 plus 4 times zeta squared omega n squared omega GC squared minus omega n raised to 4 equal to 0. Now divide by omega, divide by omega to the omega n to the power 4 on both sides. What do you get? If you divide by omega n to the power 4 on both sides, you will get omega GC by omega n the whole raised to 4 plus 4 times zeta squared into what? Into what? Omega GC upon omega n the whole squared minus 1 equal to 0. So this implies omega GC by omega n the whole raised to 4. Let us take everything on other side. Let's take everything on other side. You will get minus 2 times zeta squared plus under root of 4 zeta to the power 4 plus 1. Correct? Yes. Now, so plus or minus will be there. Correct? But now if I take this under, so this becomes square. Now see here, what happens is, here plus minus is there, correct? Yes, because both positive root as well as negative root will be there. But here negative sign I will discard purposefully. Why? Because the square cannot be negative, because this is a square, no? Here it is power to the power square, and that square cannot be negative. That is the reason I will keep it as plus only. Now, what is PM? Phase margin. What is PM? PM is equal to 180 degrees plus angle of G of J omega H of J omega at omega equal to omega GC. Correct? Why did we find omega DC first? We found out omega DC first because at the end we were supposed to find the phase margin. Correct or not? At the end we wanted to find the phase margin. That is the reason we did that. Now, anyways, moving forward to the next one. See, moving forward, what is PM now? PM is nothing but just now we see plus or plus 180 degrees plus this one, correct? Yes. No. See here. which is equal to how much? How much? 180 degrees minus 90 degrees minus tan inverse of omega upon 2 zeta omega n. Correct or not? Yes. Correct. Yes. Now, if you solve this further, what do you get? You get this to be equal to 90 degrees minus tan inverse of, come on, under root of 4 zeta to the power 4 plus 1 minus 2 zeta squared, the whole upon 2 zeta. Correct? Yes. And 90 minus tan inverse of theta is given by cot theta. Cot inverse, correct or not? This is cot inverse of minus 2 zeta square plus under root of 1 plus 4 zeta to the power 4, correct or not? The whole divided by 2 zeta, is it right? Yes. Now, since we know that now, tan inverse of x plus cot inverse of x equal to pi by 2. Remember this. This is what we had learned in school level mathematics, correct again? Yes, sir. This we had learned in school level mathematics now. Anyways, so basically, what is your PM from here? How much PM do you get here? You get PM to be equal to tan inverse of 2 zeta upon, if you simplify this, you get 2 zeta upon minus 2 zeta square plus under root of 1 plus 4 zeta to the power 4. Correct or not? This is your PM. Problem solved. Now, let us see the next question. The forward path transfer function of a unity feedback system transfer function of a unity feedback system is given by g of s equal to 1 upon 1 plus s squared. Okay, what is the phase margin of the system they have asked you? See, now what is transfer function given? G of s equal to 1 upon 1 plus s the whole square, correct? For this particular transfer function, in theory we had seen that the polar plot will look somehow like this, correct or not? Here omega equal to infinity, here omega equal to 0. Now, what is angle of g of j omega at omega equal to omega gc? It is 0 degrees, correct or not? Yes, it is 0 degrees. Therefore, your PM is equal to how much? 180 degrees plus angle of g of j omega. 180 degrees plus angle of g of j omega at omega equal to omega gc. At omega equal to omega gc. So, which is equal to how much? 180 degrees plus 0 degrees, which is equal to 180 degrees. So, phase margin is in this case is 180 degrees. So, your system is very much stable, damn stable. No problem about it. Correct? Yes. Now let us move on to the next one. The gain phase plot of a linear control system is shown in the figure below. What are the gain margin GM and the phase margin PM of the system? Correct. What are the gain margin GM and what are the phase margin PM of the system? Let us see that. What is that? By the way, is my voice proper now? Am I audible? Please, is my voice clear? Like earlier one. Even now, is it clear? Let me check. Is it clear even now? Yes, it is clear, I guess. Okay, no problem. Now let us move on to the next one. See here. The gain phase plot of a linear control system is shown in the below figure. What are the gain margin and the phase margin PM of the system? Okay. So let us see what is gain margin and phase margin. Let us do the manipulations here only. See here. We can do zoom. Okay. See, this is what whenever your gain plot reaches 0 degrees, reaches this one. So this is your omega GC. Correct. So let me draw one line here. This is your omega GC. What is this value? This is your PM, which is phase margin. Now here, this is omega PC. So here from this one to here, this one is what omega. This is what gain margin. What is this? This part here is what? It is gain margin, correct? Yes. Now, since omega PC, just observe this is omega GC and this is omega PC, correct? This frequency omega PC. Now, what do you observe here? You observe that omega PC is you observe that omega PC. Just a minute. You observe that omega PC is less than omega GC, correct? Here in this case, what has happened? Omega PC is less than omega GC. The moment you see omega PC is less than omega GC, what does this mean? What does this mean? This means that system is unstable, because if omega PC is less than omega GC, then in such a case your GM is negative and your PM is also negative. And if both GM and PM are negative, then in such a case we say that system is unstable, correct? Yes. Now, let us see the next question. The open loop transfer function of a unity feedback control system is given by GFS equal to K into e to the power minus TS, where K and T are variables and are greater than 0. The stability of the closed loop system depends on K only, both K and T only, neither K nor T. Let us analyze. Open loop transfer function is correct. This T is what? Kind of time function. This T is given for the dead zone, correct? Yes. Whenever there is a time lapse or wherever there is time delay, this thing will come. Now, where K and T are variables are greater than 0, stability of closed loop system depends. Stability will definitely depend on only one factor. What is that? That factor is K. What is your K? K is nothing but gain per turn. Because for this whole thing, your your gain is nothing but K. Because for example, if you think of like this, you have, let us say, some complex number x plus iy, correct? That is also written as r into e to the power j theta in exponential form, correct or not? Yes. Wherein this r is what? This r is nothing but magnitude or not? Yes. This magnitude is here nothing but k or not? Yes. Which is nothing but gain. So the Open loop transfer function of a unity feedback system is given by this. So here the stability of the closed loop system depends only and only on K. Why? Because rest is the angle T. T will give you the angle part. T will give you the contribution in angle, and rather it will be nothing but time constant only kind of. Okay. Anyways, so now let us move on to the next one. What is that? The Bode plot of a transfer function. The Bode plot of a transfer function g of s is in the figure below. The Bode plot of a transfer function g of s is given below. The gain 20 log of g of s equal to 30 is 32 dB and minus 8 dB at 1 radians and 10 radians respectively. The phase is negative for all omega, then g of s is. If the phase is negative for all omega, then they are asking g of s is. Let us see. What happens? From 10 radians to 1 radian, there is 1 decade, correct or not? The 10 radian, this is 1 radian. Rather, from 1 radian to 10 radian, it is how much time? It is 1 decade time, correct or not? Yes, sir, it is a time of 1 decade. Now, what next? So, in this 1 decade, what is the time? This is 32, and now it has become how much? It has become minus 8, correct or not? Yes. So, in this 1 decade, it has given 32 minus of minus 8, so it has become 44 dB, correct or not? So, can I say that the slope is what? Minus 44 dB per decade? Yes, sir. Not 40, 44, this is 40, correct? 32 plus 8 is 40. So, can I say that my slope is minus 40 dB per decade? Yes. Now, this means that there are 40 dB per decade means what? There are 2 poles at origin, yes or no? Because 1 pole contributes to minus 20 dB per decade. There are 2 poles at origin, definitely. Now, the moment there are 2 poles at origin, it means either B or D is correct. Either B or D is correct. These two are definitely gone. Now, what are we supposed to check? We are supposed to check what happens at omega equal to 100. Let us put it. Put omega equal to 1 in both options and see what happens. Because at 1 we know the value, no? Omega equal to 1 we know that the value is 32. So let us see whether you get the gain to be 32 or not. Correct or not? Yes, so let us check that. So 20 log of, let us consider option B. 20 log of, what is that? 39.8, correct? 39.8 upon s squared. So 39.8 upon s is 1 squared. This is equal to how much? This is equal to 32 dB. And let us see next one, D. D is what? 20 log of what? 32 by 1 squared. Which is equal to how much? It is equal to how much? It is equal to somewhere around 30.1 dB. Somewhere closer, approximately. So this means what is your answer? Your answer is definitely option B. Why? Because you want 32 dB, no? So your answer is option B. Is it very easy question? Is it very easy? Yes. Now next. Choose the following statements. Choose the following statements. See. Now we are entering into compensators and this one, correct? Yes. Controllers and compensators we are moving into. So let us see the first question. Consider the following statements. A proportional plus derivative controller has high sensitivity. See, Proportional plus derivative means PD controller. Correct on. P for proportional, D for derivative. Now, has what they are asking high sensitivity increases stability of the system. What is there? What is there? So before entering into this problem, let us see what are the different characteristics of a PD controller. So the first characteristic and the very important is it adds an open loop zero on negative real axis. It adds open loop zero on negative real axis, correct? Yes. So now this is the first thing. Second thing is what? Undamped natural frequency remains same and damping ratio increases. Means because of PD controller, what happens? Undamped natural frequency means omega n remains constant, but zeta, that is damping ratio, it increases because of this. Now the third point. Now, what are the next years? Peak overshoot decreases. Yes. Now, please observe here. What is the next property? Because the PD controller bandwidth increases. What did I say? Bandwidth increases. Rise time that your system takes reduces. Then effect of external noise increases. Settling time TS decreases. That is response becomes faster. And your stability is improved. And your steady state error also decreases. So basically, all good things are happening, correct? And since it is PD derivative control, so this is mostly acting on the transient response part, correct? Yes. No. They are saying it has high sensitivity and all. Yes, it has high sensitivity, right? Second, increases the stability of the system. Yes, stability of the system is increased. Improves the steady state accuracy. Yes, because ESS is reduced. Because steady state error is reduced. That is the reason we can say that it is. So it is option A. Getting my point or not? Correct? Yes. Now next. In industrial control systems, which one of the following methods is most commonly used in designing the system? Permitting perform performance specifications. Number A, the transformation is first determined and then easily earlier compensation or their the transfer function is, is first is first determined and PID controllers are implemented by mathematically determining PID constants. PID controllers are implemented without the knowledge of the system parameters using the Ziegler-Nichols method. So the PID controllers are implemented using Ziegler-Nichols method after determining the what do we say this one? So let us see what is the answer. Yes, from all of this, the answer is option C because PID controllers are implemented without knowledge of system parameters using Ziegler-Nichols chart. Correct. In industries, in industrial control systems, it is done. Rest it is not done. Correct. Yes. Now next, considering the filtering property, the lead compensators or lag compensators are categorized respectively as lead and lag compensators are categorized as what? Always remember, lead compensators are categorized as high pass filters and lag compensators are categorized as low pass filters. Okay, always remember this. High pass and low pass, option B. Just very simple questions are asked. Now next. Consider derivative feedback is employed in the control system shown in the figure. To improve its damping, if the required damping factor of the system is 0.5, the value of KD must be adjusted to. Means they are asking that the damping factor of the system is 0.5, they are given, and they are asking a value of KD must be adjusted to what to improve the damping. That is what they are asking. So some requirement is given, and based on the requirements, you have to tune the value of KD such that it is met. Okay. So before that, let us simplify the diagrams, or rather, let us use the block diagram reduction techniques. If you see this block and then feedback is a zero feedback. Similarly, whatever block that we get here will be again feedback with this one, correct or not? Yes, sir, definitely it will be feedback. Moral of the story, let us do that. So for internal, for this one calculation, let us calculate this one. So what is that? 1 upon s into 4s plus 1 KDS goes here, correct? Therefore, now what does it happen? GFS 1 upon s into 4s plus 1. 1 upon s into 4s plus 1, correct? The whole upon 1 plus s into KD upon s into 4s plus 1, correct? Yes. If you simplify this, you will get 1 upon 4s squared plus s into 1 plus KD. Is it right? Yes. Now, this whole block I will replace in place of here. So basically, I will be having block like this. 100 is there already, and after that I will be having this 1 upon 4s squared plus s into 1 plus KD. This thing will be there. Now you want to find the transfer, simplify the above block diagram. So these two are in series, so they get multiplied, and this, and here you have got 1 which is in negative feedback. So simplify this, you get GFS to be equal to how much? 100 upon 4s squared plus s into 1 plus KD. Getting my point? Yes. Upon 1 plus 100 upon 4s squared plus s into 1 plus KD. Yes. Now, after simplifying this, what do you get? You get it as 100 upon 4 s squared plus s into 1 plus KD plus 100, correct? Yes. It is equal to almost 25 upon s squared plus s into 1 plus KD upon 4 plus 25, correct? Yes. Now let us compare it with standard equation. If we compare this with the standard equation, what is standard equation? Standard equation is omega n squared upon S squared plus 2 zeta omega ns plus omega n squared is the standard equation. Yes. Comparing it with standard equation, what do you get? You get 2 zeta omega n to be equal to this one. So you get 2 zeta omega n equal to how much? 1 plus kd by 4, correct? Yes. Now what is zeta omega n? 0.5 into 5. So this is 5. So it is 2 into what? Zeta is 0.5 given multiplied by omega n. Omega n how much? 5 is equal to 1 plus kd by 4. 4 again goes there. So you get 2 into 5, 10. 2 into 5, 10. 0.5 into 4 is 2. So you get here 10 and 1 plus kd. So 20 equal to 1 plus kd. Therefore, you get kd value to be equal to 19. Getting my point? Getting my point? Is it very easy? Is it very easy? Yes. Now next, consider the following statements. The effect of phase lead network is as shown. Phase lead network is as shown. Okay. Yes. Let us write down what are the effects first. The first effect is your phase margin increases. What did I say? First effect is that your phase margin increases. Second thing, your bandwidth also increases because of lead. Bandwidth is also increases. Then what? If bandwidth is increased, your response will definitely become faster. Correct or not? Now, response is faster. Last point. Steady state. See, all of these points are interrelated to each other only. Nothing is separate from each other because one parameter depends on another. If EM is increased, definitely bandwidth is increased, definitely response is faster, kind of. Fourth one is what? Steady state error that is not accepted. Okay. The fourth one is what? Steady state error ESS remains constant with the lead because lead compensator actually acts on the transient response, not on the steady state response. Okay. Yes. So basically, what? Increased phase margin is correct. 2 and what do we say? Increased bandwidth is also correct. Rest is wrong. Wrong. So answer is option 3. Get to my point? Correct. Yes. Now let us move on to the next one. Two compensators have. Let us say two compensators have transfer function g1 of s equal to 5 into s plus 10 upon s plus 50 and g2 of s is equal to s plus 50 upon 5 into s plus 10. They are asking you. Both are lag, both are lead, g1 is lead, g2 is lag. What is that? See, in such cases, what do? You please stand on origin. Whichever system's transfer function pole is near to you is lead. Whichever is far to you is lag. That's it. So which is near? So on this one, what is that? So answer is option C. G1 is lead and G2 is lag, correct? Yes, sir. G1 is lead and G2 is lag. Now let us see one more question. The transfer function of a controller is GC of S. Is GC of S equal to 1 plus 3S upon 1 plus S. The maximum phase provided by the controller is. They have given you the transfer function and they are asking you what is the maximum phase given by the transfer function, correct? Yes. Okay, yes. So let us see that what happens. Let us see. Transformation of the controller. What is that given? GC of S is equal to how much? 1 plus 3S upon 1 plus S. Correct? Yes. Where is your 0 here? 0 is given by numerator. So 1 plus 3S equal to 0. If you equate, you get S equal to minus 1 by 3. Correct? Yes. So it is your 0. Where is your pole? Pole is nothing but S equal to minus 1. It is your pole. This is 0. This is pole. This means that you are given controller because see 0 is first and afterwards pole is there, which means 0 is first, no? Which means 0 is first. If your 0 is first, see if you stand here on origin, what do you observe? Minus 1 by 3 will be somewhere here and minus 1 will be somewhere here. So basically what has happened? Minus 1 by 3. Basically, if you just observe here what has happened, you have got 0 coming first. 0 comes first. If 0 comes first, what does that mean? If 0 comes first, it means the given controller is a phase lead controller, which is a phase lead controller whenever 0 comes first. Okay, so it is a lead controller. Now, what is total phase? What is total phase over here? Total phase is how much? Total phase is, let us consider delta, which is tan inverse of 3 omega minus tan inverse of omega. Means angle which is on top minus angle which is on the bottom. So let us differentiate it. So d by d omega equal to 3 by 1 plus 9 omega squared minus 1 upon 1 plus omega squared equal to 0. Is that correct? Is that correct? Yes. Therefore, what do you get? You get 3 plus 3 omega squared minus 19 omega squared equal to 0. Therefore, you get 6 omega squared equal to 2. Correct or not? Yes. Therefore, omega equal to 1 over under root of 3. Therefore, what is phi? Phi is what? Come on, tan inverse. In place of omega, just replace 1 by omega 3. 1 by under root of 3. So you get tan inverse of 3 by under root of 3 minus tan inverse of 1 by under root of 3. That's it. Which is equal to how much? 60 degrees minus 30 degrees equal to 30 degrees. So your answer is how much? Your answer is 30 degrees. So where is 30 degrees? Option A. 30 degrees lead. Because leading why? Because you see 0 first. That is the reason it is lead. If you see pole first, it is lag. Anyways. So this is the answer. Now, last two questions only remaining. See, a proportional controller, with transfer function Kp is used with a first order system having its transfer function as Gc of s equal to k upon 1 plus s tau in unity feedback nature. For step inputs, an increase in Kp will. So let us see what happens. Gh of s equal to how much? K upon 1 plus s tau. They are given. Correct? Yes. What is Gc of s compensator? They are given Kp. The rest it is again Kp. Correct? Kp is used in first order system having transfer function. Proportional controller only means only K will be there. Proportional, only gain will be there. So what is the closed loop transfer function for this? It is nothing but K times Kp upon 1 plus S tau plus K times Kp. Correct? Yes. Which is equal to how much? K into Kp upon 1 plus K into Kp, the whole divided by T upon K into Kp into S plus 1. Therefore, what is time constant now?
What is time constant now? It is equal to T upon 1 plus K into Kp. Therefore, what is ESS? ESS is equal to how much? ESS is nothing but equal to 1 upon Kp, we know. So 1 upon K Kp. Therefore, what do you observe here? What do you observe here? You observe that if Kp is increased, both time constant and ESS reduces. Time constant reduces here, and also ESS also reduces. So what is the answer? The answer is option B. It decreases time constant and decreases the steady state error. Both. So proportional controller, again, what we can observe from here? We can make a note. Proportional controller decreases the time constant as well as decreases the steady state error of the system. Is it correct? Is it right? Yes. Now let us see one more question. In position control systems, the tacho generator feedback is used to see. Tacho generator, always remember, make a note of it. Tacho generator is essentially nothing but what? It is essentially nothing but what? A derivative controller. Correct? It is a derivative controller. Now, the moment I say it is a derivative controller, so it is used mainly for transient parameter. So in transient parameter, the first parameter comes to be zeta, because we are talking about tacho generator. No, so first we need damping. Damping is our point of interest, correct? Yes. Now, therefore, what is that? Zeta new equal to zeta old plus kd into omega n upon 2 is a formula we should know. So, what do you understand from this? Whereas this kd is nothing but what? Tachometer constant it is given. Now, if kd is tachometer constant and see this way, so what do you get now? What do you get now? You get if what if you increase the damping of the system? If damping of the system is increased, what will happen? Definitely new damping will be increased. Correct? Definitely this new damping will be increased. That is the reason we can say that answer is option A. Getting my point? Is everyone okay with that question? Now, I'm going to have a bonus question for you. One extra bonus question for you. Correct? Yes. A phase lead compensating network has its transfer function GC of S equal to 10 into 1 plus 0.04 S the whole upon 1 plus 0.01 S. Correct? Then they are asking the maximum phase lead occurs at a frequency of, and they are given options. Option A 50 radians per second, option B 25 radians per second, option C 10 radians per second, and option D 4 radians per second. So this is what they have given, and they are asking you to find out maximum phase lead occurs at what frequency. That frequency they are asking. Okay. So what is GC of S first? GC of S is given by how much? 10 into 1 plus 0.04 S upon 1 plus 0.01 S, correct? Yes. Now, comparing with standard phase lead compensating network. So what is standard lead network? What is standard lead transfer function? Then nothing but alpha into 1 plus T1S upon 1 plus alpha t1 is correct. This is the transfer function, standard transfer function, correct? Yes, if you compare them, what do you get? You get alpha t1 equal to 0.1s, and here you get t1 to be equal to 0.04s, and similarly you get alpha to be equal to 10. So basically, what is t1? T1 initially is 0.04. What is alpha? Alpha is 10. What is alpha t? Alpha t1, it is nothing but 0.01. Since alpha is 10, so t1 is nothing but what? 0.001. Correct or not? Yes. Now, maximum phase rate occurs at omega n. So, what is that? Omega m is nothing but given by how much? The formula is 1 upon under root of alpha t into under root of t. It is the formula, correct, for the frequency at which maximum phase occurs. What is that formula? This is this one. So 1 upon under root of 0.04 multiplied by under root of 0.01, which is equal to how much, sir? 50 radians per second. Is it right? Is it right? Please tell me, yes or no? Yes, no. Correct. Yes. So these were the problems which we addressed in this particular session, wherein we had frequency domain as well as compensator problems as well. So that's it for now. We'll definitely meet in the next session, probably tomorrow, with electrical networks. Okay, chalo then. Bye bye. Take care. See you. Good night.